Depends on how you feel about algebra. We're taking a break from geometry for the next 3 days.
Let's go.
It is related to geometry in ways, but this is basically a recap of some of the really important things we talked about in algebra. Okay, so here's what I told last hour. Typically, in Algebra 1, okay, we're going to talk about 3 main things today. We're going to talk about slope of a line, how to graph a line, and then writing the equation of a line. In Algebra 1, I would usually spend 1 day on slope, probably 2 on graphing, and at least 2 on writing the equation of a line. So I'd spend a week on something we're going to review in 1 day. It is a review. You learned it last year. But I'm just letting you know it's kind of a lot of information today. But we're going to kind of do the same thing tomorrow. So not going to add too much to it tomorrow. So just kind of throwing that out there. So let's go ahead and let's get started on these things we're going to review today. So today we're talking about lines in the coordinate plane. So when we talk about a line, graphing a line, writing the equation of a line, anything to do with lines in the coordinate plane, one of the biggest things that you can know about a line that's going to be helpful is the slope of the line. So the slope of the line basically tells you if the line's going to slope up or if it's going to slope down. It'll tell you how steep the line is. The bigger the number, the steeper the line. It could tell you if it's going to be a horizontal or a vertical line. But we're going to be really interested in how to find slope. Now, if you had me last year, I explained this last year, but I teach slope differently than your teacher that wasn't me last year probably did. I think my way is probably easier, which is why I teach it this way, but I will show you both ways. If you want to use how your teacher taught you last year, because it makes sense, that's fine. If I show you my way and you want to use my way, great, that's fine too. As long as you get the right answer, I don't care. So slope, okay, like I said, tells you the shape of the line. If you're actually looking at the line or if you're graphing the line, it tells you how the line is going to rise over run. So like if you had a slope of 1/4, it means that anywhere on your line, you could rise 1, run 4, and you'd be back on the line. Okay? Now, to find slope in different ways, like if you're given points, if you didn't have me last year, this is probably the formula you were taught. y2 minus y1 over x2, I forgot a little 2 there, over x2 minus x1. If you had me last year, I taught you how to do change in y over change in x. Now, before you start wondering with all of this excitement what change in y over change in x means, it's the same thing. Think about it. In math, if I said the temperature today changed from 100 to 80, what's the change? 20. How'd you do that? Subtraction. Math. Somebody said that last hour too. No, you subtracted, right? You took 100 minus 80. You subtracted. So the change, that's what that triangle means. The change in y is just the difference in the y values, which is exactly what you're doing in the formula. And same thing with the change in x. Okay? So we'll practice with slope a little bit. And then there were 2 main forms of the equation of the line. One is called slope-intercept form. Slope-intercept form is definitely my preference whenever it comes to writing the equation of a line, or if I'm given a line, how I would like it seen. And I will say this a couple times today. Your answers today, I don't care what the back of the book says. I don't care what Slater says. I don't care what Photo Math says. I want your answers in slope-intercept form. Okay, we'll talk more about that, but just kind of putting that in your heads already, okay? Slope-intercept form looks like this. Y equals mx plus b. Now the thing is, whenever you actually have an equation in slope-intercept form, you're not going to see the letter m. There's going to be a number here. Do you remember what that number is? Slope. M is going to be the slope of the line. And you're not going to see the letter b. There's going to be a number there. Remember what b is? Y-intercept. That tells you where the line crosses your y-axis. If you have an equation in slope-intercept form, it is super, super incredibly easy to graph. Okay, we'll talk about that down below. Now, when we're writing the equation of a line, there are 2 methods to write the equation of a line. If you had me last year, since we were short on time, I only showed you 1 method. But if you didn't have me last year, you may have learned how to write the equation of a line just using slope-intercept form. And that's great, but since we're cramming this all in one day, I'm going to pick and choose, and I'm going to go with what I think is easier, and I think it's easier to use point slope form. So, how point slope form works, it looks complicated, but it's super easy to use. Point slope form says y minus y1 equals m times x minus x1. But kind of like with slope intercept form, how you're not going to see the letter m and you're not going to see the letter b, you're not going to see that y1. You're going to plug a number in right there. And you're not going to see m or x1. You're going to plug numbers in there. Now, the number you plug in for m is going to be slope. Now, the numbers that you plug in for x1 and y1 is going to be a point. So they're going to give you some kind of information that says, this line has a slope of this, and it passes through this point. How point slope form works is it takes that point, that x and that y, and it plugs it into the equation. Super easy. I know it looks complicated, but you literally plug the numbers into the equation, and you have the equation of the line. Now, like I said, though, your book likes to leave the answers in point slope form, which is fine. It's not incorrect, but I definitely prefer slope intercept form. It's easier to graph. It's easier to tell more about the line, so we're always going to turn it from point slope form into slope intercept form. And we'll practice that over here on the right. Okay? Now, before we get down to graphing and actually writing the equation of a line, let's go back and talk about slope. So, there are four main types of slope. Okay, you have positive slope and negative slope. Most of the time, your line is either going to slope up or it's going to slope down. When you find your slope, if it is a positive number, your line is going to slope up. If you were to walk along that line from left to right, you would be walking uphill. If, when you find your slope, it's a negative number, your line is going to slope down. Be a negative slope. Now, these two are the two that are really easy to confuse. Okay? If you have a horizontal line, it's a zero slope. If you have a vertical line, it's an undefined slope. And I understand. They're so similar, and it's hard to keep them separate. So I have ways looking for you guys how to remember this. So first of all, not that yet, okay? First of all, if I asked you to draw me a line that has a zero slope, you're like, I can't remember if that's the horizontal one or the vertical one, what you need to think about is the z. The z has zero slopes on it. Right? And guess what? An undefined slope, look at the U. What does it have? Undefined slopes on it. Isn't that convenient?
Yeah.
You guys see it? Okay?
Yeah.
So a zero slope, think about the Z's. Undefined slope, think about the U's. Okay. So I think that was a little easier to remember. But what's easy to confuse is what the equations of these look like. When you look at the equation of a positive slope or a negative slope, it's going to look like a normal equation. Y equals 2x plus 3. Y equals negative 3x plus 4. Okay? It's going to look like a normal equation. It's going to have an x and a y. It's going to have some numbers. The zero slope and the undefined slope are going to look a little different. When you look at the equation of a zero slope, it's going to have y equals a number. And that's it. Like it might say y equals 2, or y equals negative 1, or y equals 5. But there's not going to be an x. It's going to be a y-only equation. And the undefined slope is going to be the opposite. Its equation is only going to have an x. Like x equals 2, or x equals negative 1. But it's going to be an x-only equation. These are the ones that I find students have a harder time keeping separate. Okay? So looking for you guys, I have a way to remember this as well. Okay? When you see an equation and it's a y-only line, you guys can already see my former students doing this, okay? When you say y, when you're like, why is math class so fun? Right? Okay? Why? Is everybody so tired this week? Right? Why? You guys see what you do with your hands whenever you say why? Yeah, and you think it's being silly, but yeah, it's kids from last year. You'll be on a test, you'll be like, y equals 2, y. Like, make sure nobody's looking at you like, okay, yeah, so we're the horizontal line. You'll use it, I promise, okay? So a y-only line looks like this, okay? Now an x-only line, x like an axe. Yeah, they look like x's. Yeah, okay. X like an axe. What does an x do?
Chop.
I guess unless you're going down the street, and then it's the opposite. But no, we're going like this, okay?
Do that.
X down like this, okay? So we have our zero slope is a y-only line. Our undefined slope is an x-only line. Okay? That's how you can remember those if you have a hard time keeping them separate. Okay, now let's put some of this to use here. Let's talk about graphing a linear equation. Now, luckily for you guys, I don't think in your homework you have to do this first step, which is the hardest step. So, if you're going to graph a linear equation, the first thing you have to do, the most important thing you have to do, it has to be in slope-intercept form. It has to be in y equals mx plus b. If it's in y equals mx plus b, it takes like 2 seconds to graph. This is the part that takes a long time to do, is rewriting it in slope-intercept form. Once it's in slope-intercept form, to graph a line, you need 2 points. When it's in slope-intercept form, you have one of the points. You know where the line crosses the y-axis, so you can plot that point. Well then, remember, the slope tells me what the line's doing. It tells me how it's rising and running. So if I start at that point and rise over run, I can find out where the rest of the line is. Okay, and I can plot a second point. So let's look at this example here. So the first thing we want to do, the most important thing we want to do, it has to be in y equals. I need to solve this equation for y. So what's the first thing I do here? Yep, I got to move the x over. So since it's a positive x, we're going to subtract x from both sides. Now when I do that, I still have negative 3y equals. I prefer to write the x first. And remember, the sign in front of the term is what travels with the term. So that's going to be a negative x. And the 12 is going to be a plus 12. And then to get rid of the negative 3, we would divide by negative 3. You have to divide both sides, and you have to do a big division bar over there on the right, so it's going to be y equals. Now, once again, if you had me last year, I've got all these fun phrases to help remember things. What we do here is what I call the butterfly method, okay? So instead of taking these two divided by one thing, you can take negative x divided by 3 and 12 divided by negative 3 to make a fun little butterfly. So when you take negative x over negative 3, first of all, negative over negative is a positive. But what I want you to do here is I don't want you to leave it as x over 3, because we're going to need to find the slope. And the slope is the number in front of x. And this doesn't really have a number in front of x, it has a number underneath x. So whenever this happens, what I teach you to do, there's a 1 in front of the x, we just don't usually write it. So write the 1 in front of the x, and then kick the x out of the fraction. So we can rewrite it as 1/3 x. And then we'll take 12 over negative 3, which is a negative 4. So once it's in y equals, we can say, okay, the slope is 1/3. The y-intercept is negative 4. Now remember what the slope tells me? It gives me a really, really good idea what the line looks like. This line is going to rise 1, run 3, rise 1, run 3. I can already tell you without actually graphing this, it's going to look about like that. Rise 1, run 3, be back on the line. Here's the problem. I don't know if it's going to rise 1, run 3 down here, up here, up here. I have no idea where it's going to be at. So what I have to do first is plot the y-intercept. Now remember, this needs to be plot on your y-axis. So what this tells me is that my line crosses my y-axis at negative 4. That's where my line's at. It's going to look like this. So once I plot that point, then I can rise 1, run 3, and plot a second point. And you just have to do 2 points, and you can make your line. Now, like I was saying, I think on your homework, I'd have to glance to make sure, but I think on your homework, they're all in y equals or in a form that you can graph them. So the hard part, questions on graphing? Okay, now, like I was saying, whenever we are writing the equation of the line, I am going to ask you to always write your answers in slope-intercept form. If you're checking your answers in the back of the book, there's going to be some times where they have their answers in point-slope form. Because it's easier. You just plug the numbers in and that's it. And point-slope form is super easy to use, it's just not that useful. So I would like you to put it in point-slope form, if necessary. Put it in point-slope form. All of your answers should look like this. All of your answers should be a slope-intercept form equation. Okay? Now, sometimes you're not going to need point-slope form. your answer like this, you need a number to plug in for M and a number to plug in for B. So there's going to be some problems where they just give those to you. They're going to say, write the equation of a line that has a slope of this and a y-intercept of that. If they give those to you, just plug them in. Now, if they don't give them to you, you are going to use point-slope form. Now remember what we talked about. Point-slope form, you need a number for y1, m, and x1. The x1 and y1 they will always give you. They will always give you a point, or sometimes two, that you can use to plug in for x1 and y1. What they won't always give you is the slope. So sometimes you're going to have to find the slope, which, once again, I do change in y over change in x. You could do y2 minus y1 over x2 minus x1 if you'd like, but sometimes you have to find the slope. Once you find the slope, you're going to plug in values for the slope for x1 and y1. Then you have the equation of a line. That is an answer, but to put it into slope-intercept form, you're first going to need to get rid of the parentheses, so you're going to have to distribute the slope, and then you're going to have to get rid of that number here. So let's look at this answer, this example down here. So I want to write the equation of a line that passes through negative 2, 3 and 2, 1. Okay, unless they give you the slope and y-intercept, you're going to have to use point-slope form, which they don't give me the slope and y-intercept, so we're going to use point-slope form, which is y minus y1 equals m times x minus x1. And to use point-slope form, I need a y1, an m, and an x1. Now, they give me 2 points that this line passes through, so I've got the x1 and y1. Now, with the x1 and y1, it does not matter which points you pick. It doesn't matter. What does matter is if you're going to use this x, you have to use this y. And if you use this x, you have to use this y. You can't mix and match them. Okay? What I don't have is the slope. So the first thing I have to do here is find the slope. Now, I'm going to do change in y over change in x. And then I'll show you that you get the same thing as if you do it the other way. Now, here's how, if you haven't done this before, here's how you do change in y and change in x. To do the change in y, you're going to look at your two y coordinates, 3 and 1. And you're going to kind of picture a number line. And you're going to act like, okay, you're standing on 3 and you need to get to 1. You need the direction and the distance. So what's the direction from 3 to 1? Negative, right? Going backwards. And what's the distance to get from 3 to 1? 2. So it'd be minus 2. The change in y is minus 2. Guys, look at this. If you did y2 minus y1, 1 minus 3, what do you get? Negative 2, right? Okay? For the change in x. Once again, kind of picturing a number line here. If you're going to start at negative 2 and get to a positive 2, what's the direction? To the right, positive. And how many from negative 2 to a positive 2? 4. So you're changing x is 4. But guess what? If you do x2 minus x1, 2 minus a negative 2, would be 4. I don't like doing it, the y2 minus y1 or x2 minus x1 because whenever you have to minus a negative, it always gets screwed up. I really like the change in y over change in x. If you like the y2 minus y1, you're welcome to use it, but this is what I'll do my examples as. Okay? Now, we need to, with slope, we always need to reduce it, so negative 2 over 4 would reduce down to a negative 1/2. Okay, so the next thing we're going to do is we are going to plug in our numbers. Now remember, it doesn't matter which points you choose. For this one, I might use 2, 1, just because they're both positive. And we're going to plug in 2 for x1 and 1 for y1. So it's going to look like this. Y minus, instead of y1, we'll plug in 1. My m, my slope, we just found that. It's a negative 1/2. And then x minus, the x1 comes from your point. So I'm going to plug in 2. Now, this is the equation of the line. This would be an acceptable answer for some teachers, but I am not some teachers. I would like you to write your answer in slope-intercept form. So there's always going to be 2 steps. First thing, you got to get rid of these parentheses. So you're going to distribute your slope. So you'll leave the y minus 1 as it is. We'll do negative 1/2 x. Don't forget to distribute this to the second number. Negative 1/2 times a negative 2 is going to give me a plus 1. And then lastly, to get into y equals, I just need to get rid of the minus 1. So I will add 1 to both sides. We have y equals negative 1 half x plus 2. There's the equation of your line. Okay, let's get this glued into page 43. We are skipping section 3.6 and going to section 3.7. And this is called equations of lines in the coordinate plane. Alright, so 3 main things we're doing today: finding slope, graphing a line, and then writing the equation of a line. So let's start with finding slope. Once again, I know I've already said it a couple times. I'm going to do change in y over change in x. If you're going to do y2 minus y1, x2 minus x1, that's fine. Just make sure you're getting the right answer. So number 1, let's find the slope of the line that passes through negative 1, comma 0, and 3, comma negative 2. Okay, so to do change in y over change in x. The big thing, you have to make sure you go from one y coordinate to the other y coordinate. I find it really helpful to picture a number line in your head. So if you were starting at 0 and you needed to get to negative 2, you have to include a direction, which would be negative, and a distance. So from 0 to negative 2 would be minus 2. And then for your change in x, from negative 1 to a positive 3, so this time it's going in the positive direction. So it would be plus, and what's the distance from negative 1 to 3? Plus 4. Now remember, slope, we want to make sure we write our answer in simplest form. So negative 2/4 would reduce down to negative 1/2. Number 2, let's do negative 2, comma 3, negative 4, comma 7. All right, so change in y over change in x. So my change in y from 3 to 7, what's that change? Plus 4. Remember, we got to include a direction and distance. Now from negative 2, I sometimes really have to think extra hard anytime you're going from a negative to a negative. On a number line from negative 2 to a negative 4, you'd be going in the backwards direction, so you'd be going negative, and then it would just be 2. So 4 over negative 2 would give you a slope of negative 2. And last one of these, number 3 says negative 2, comma 6, negative 5, comma 6. So change in y over change in x. Now my change in y from 6 to 6, 0, no change there. Change in x, negative 2 to a negative 5, negative 3. What's 0 divided by anything? 0. What does a 0 slope line look like? 0, yeah. 0, think about the z's. Yep. Very good. Okay, questions on finding slope. All right, let's talk about graphing a line. Here in your notes and in your homework, I don't give you graph paper, so you're just going to sketch your graphs. They don't have to be perfect. Just kind of get the general idea. So we want to graph each line. Let's do y equals negative x minus 3. Now to graph a line, preferably, I like it in slope-intercept form, which means it needs to be in y equals, which this one is. So if it's in y equals, I should be able to identify my slope and my y-intercept. Now my slope is the number in front of x. What's my slope? Negative 1. Now, remember, slope is rise over run, so I really prefer to write my slope as a fraction. How would you write negative 1 as a fraction? Negative 1 over 1. And what's my y-intercept? Negative 3. It's going to be that constant. Remember, the slope, negative 1 over 1, first of all, I should already be picturing that this line's going to slope down. And a line that has a slope of negative 1 is going to go down 1 over 1. Now, I'm not really sure if this is going to go down 1 over 1 here, or way up high, or way down low. How you're going to know is that y-intercept. So the first thing you're going to do is plot your y-intercept at negative 3. That's where your line crosses. So from there, you can go down 1 over 1, and you have your line. Okay, number 5, y equals 1/3 x minus 4. It's already in y equals, so I should be able to identify my slope and my y-intercept. My slope is 1/3. My y-intercept, -4. Which of these do I plot first? You're going to go down 4 and put a point. And then what does my slope tell me to do? Up 1 over 3. Rise 1, run 3. Now, not all of your problems today are going to be in slope-intercept form, but that doesn't necessarily mean you can't graph them. So number 6, what if it looks like this? Y plus 2 equals -2/3 times x minus 4. Now this isn't y equals. What form is that in? That's in point slope form. Now here's the thing. In slope-intercept form, it tells me the y-intercept, so I plot the y-intercept and then I use the slope to plot a second point. You don't have to start at the y-intercept. You just have to start on the line. It's nice if it's the y-intercept, but it doesn't have to be. If you know where the line is at, you can use the slope to plot a second point. So you don't have to put this into slope-intercept form. You can graph this using the point that it gives you and the slope. So let's start with the slope. What's the slope of this line? -2/3. Okay, now, remember, these are the form y minus y1 equals m times x minus x1. I need that point. I need this x1, y1, but you have to be careful because when you plug these numbers in, keep in mind that when I plug the x in, I say x minus whatever x is. So when I'm finding my point, it's going to be x minus 4. So it kind of looks like the 4 is negative, but keep in mind the formula is x minus x1. If I were to plug 4 in there, it would be x minus 4. Well, look what happens with the y. Although the y looks positive, it's actually going to be a -2. Because think about it. If you were to plug -2 into your formula, y minus a -2, that's how you get the +2. Now, once you get these two pieces of information, you're going to do almost the exact same thing we did with the other ones, except you're not going to start at the y-intercept. You're going to start at 4, -2. You're going to plot a point there at 4, -2, because that's a point on your line. And then you're going to use your slope to plot a second point. So you're going to go down 2 and over 3. That would be the same line than if you did put it into y equals. So it doesn't necessarily have to be in slope-intercept form. I think it's easier, but it doesn't have to be. Let's do one more of those. Let's do y minus 1 equals -3 times x plus 4. Yes. 4. Got it? Okay. Alright, so number 7, same idea, it's in point slope form. So my slope would be -3. I like to write it as -3 over 1. Okay, and the point, if this is x plus 4, what's the x coordinate of my point? If this is x plus 4, it'd be a negative form. Because remember, the formula says x minus x1, so x minus a -4 would give me a +4. The y coordinate is +1. So we are going to plot a point at -4, 1. And then my slope says to rise -3, run 1. So be a line right there. Questions on graphing? Okay, let's do 2 on writing the equation of a line. And then we'll end with an easy one here. All right, so once again, I think I've already said it a couple times. I want your answers in slope-intercept form. I don't care if the back of the book has it in point-slope form. I want your answers in slope-intercept form. So number 8, I want to write the equation of a line that has a slope of -1/4 and passes through -4, 1. Unless they give you the slope and y-intercept, you're going to use point-slope form. Y minus y1 equals m times x minus x1. Unless they give you slope and y-intercept, you got to use point-slope form, which means you need a y1, an m, and an x1. And this time, they give me all of that. So to use point-slope form, you just plug the numbers in. So we're going to do y minus, my y-coordinate is 1, so y minus 1, equals my m, my slope, they tell me, is a -1/4. And then I'm going to do x minus a -4. That's how you end up with the +4. Now, this is what you would probably see in the back of the book, because they're going to leave it as point-slope form. I want you to turn it into slope-intercept form. So I need to get rid of the parentheses. So we're going to distribute the -1/4. So y minus 1 equals -1/4 x. -1/4 times 4 would give me -1. And then to get it into y equals, I need to get rid of the -1. So I would add 1, and we get y equals -1/4 x, and the -1 plus 1 cancels out. Okay, then to take it one step further, if I've just given 2 points. So I want to write the equation of the line that passes through -2, -2, and -6, -4. -2, -2, and -6, -4. Now once again, unless they give you the slope and y-intercept, you're going to have to use point-slope form. Y minus y1 equals m times x minus x1. Now remember though, I need y1, m, and x1. This time I don't have that slope. So the first thing I have to do here is find that slope. And this is where I do change in y over change in x. So my change in y, from -2 to -4, what's that change? Minus how many? Just -2 to -4? 2, 4. Yeah, -2, -4 would be a -2. And then you're changing x from -2, move a little bit further to -6, -4. A negative over a negative is a positive, and then 2 over 4 would be 1/2. Now you have to pick one of your points. I might pick -2, -2, just because it's the same number. We're going to do y minus a -2 would be y plus 2. My slope we found is a positive 1/2. And then x minus a -2 is also going to be a plus 2. And then to get it into slope-intercept form, we're going to distribute y plus 2 equals 1/2 x. 1/2 times 2 would be plus 1. And then get rid of the 2. So subtract 2 from each side. So we have y equals 1/2 x minus 1. Okay, the last thing we're going to talk about is horizontal and vertical lines. So here's what you're going to do. In your homework, it splits it up into 2 sections. It's going to do this, and then do this. We're just going to do it in one. So I'm going to give you a point. I want to write the vertical and the horizontal line that goes through that point, and then we're going to graph those lines. So for number 10, let's do the point -2, 5. So I want to write, first of all, the vertical line that passes through the point -2, 5. I want to write the equation. What does the equation of a vertical line look like? X equals. Okay, we got that. Now, what in the world? How in the world am I going to figure out what X equals? X, comma, Y. X equals -2. That's it. That's all you got to do. Okay? And then a horizontal line. What does the equation of a horizontal line look like? A Y only. And what in the world? How am I going to figure out what Y equals? It's 5. Yeah. Okay. And then to graph these, we know an X-only line is a vertical line on your X-axis at -2. That's where you draw your vertical line. For the Y-only line, on your Y-axis at 5, that's where you draw your horizontal